1928, Paul Dirac predicted the existence of antimatter when he realized an equation explaining the behavior of electrons worked with a positive and a negative answer. Much like how an x squared equals 4, the answer is 2 and negative 2. 4 years later, Carl Anderson proved Dirac right by observing an oppositely charged electron, now known as a positron, in a cloud chamber. Most scientists brush these observations aside, like when you're in math class and get an answer that you're sure isn't right, you assume you're wrong and try something else. Not these guys. They pushed the investigation that ultimately led to one of the greatest discoveries in history. Antimatter. It has the same properties as matter, but with an opposite electric charge. When a matter particle meets an antimatter particle, they annihilate, releasing 100% of their mass into energy. This process is called annihilation, and it's what makes antimatter such an efficient form of propulsion. This means that we can travel further distances with only a few grams of fuel, which are billions of times more powerful than chemical energy used today. To do this, we're going to need to be able to create it, contain it, and control it. Positrons can be created from a particle accelerator or emitted from a radionuclide, such as sodium-22, like they use at CERN. They gather antiprotons by shooting a proton beam at a metal plate. These antiprotons are extremely hot, so they are directed toward the antiproton decelerator. The decelerator uses magnets to guide the particles around the machine to cool them. Once they are moving only 10% the speed of light, they are passed through a degrader to further cool them. The Alpha project, based at CERN, has a trap of electric and magnetic fields that holds a cluster of positrons in the center and then introduces these cooled antiprotons. If an antiproton can trap a positron, they form antihydrogen. Now imagine you have this substance. You can't touch it. You can't touch your equipment. It can't even touch the air. How do we contain such a thing? Positrons and antiprotons both have electric charges, so scientists can contain them within electric and magnetic fields. The particles must be cooled so that they're not so energetic and don't move around as much. Antihydrogen doesn't have any electric charge, so it must be contained within magnetic fields like an alpha's trap. The longest amount of time that antiprotons have been able to be stored is 405 days by the BASE project. The Alpha project has been able to trap antihydrogen for just over 16 minutes. These are huge breakthroughs, however they are far from our needed storage capabilities. If we are able to create and store enough antimatter to get it into a rocket, how can we control it? The energy produced can be used directly by utilizing a magnetic nozzle to move the energy through a thruster, or indirectly by using the energy to heat a liquid propellant like in this design. Humans have always been excellent at creating the tools needed for exploration. It's in our nature. Whether it be positrons, antiprotons, or antihydrogen, I am positive that antimatter is going to be the future of space travel.